Right.
Okay.
That's what I think.
Don't do anything. You don't want all four of my viewers to see because you're right there.
Got 4 viewers.
You're on camera. Can I say hi? Can
Here
I
we
say
go.
hi?
No. Here we go. Problem
I
number one.
need
What I'm
to
going
go.
to list here is, I'm going to go through and I want to list the ones we think are false. So, for number one, which one did you decide was false? The third one? Statement 3 is false? And why did you say it was false? It's concave up. The whole thing is concave up, right? Okay, that was easy. Right, what about number 2? Which one did you say was false? 3 again? And what was false about that one? On the interval they're talking about, from -4 to -3, that is concave up, right? Easy, no problems. All right, how about number 3? 3 again? And what was wrong with it? From -1 to 3, it's partially concave down and concave up. So that we just wanted to focus on the concave up part, maybe we would say from 1 to 3. That would be concave up? Okay. All right, what about for problem 4? 2 is the false one. What's wrong with that one? It's definitely concave down on that interval. Would you agree? But it's increasing from like 5 to 6, and then it's decreasing. So maybe change the 7 to a 6, and then it's true. All right, how about 5? What did you get for 5? 2 is the false one. What's wrong with it? It has an open circle, so let's clarify our vocabulary. What is a 0? An x-intercept, right? That means there's a point that's something comma 0. You don't have that at 3. You have it at 2, and you have it at 5, but you don't have it at 3 because there is an open circle, right? That is not a 0. That point is not there. Okay, problem 6. Which one there?
3.
What's wrong with 3? Remember, we are looking at, this is a very poor thing, but when we look at this picture, if we're talking about x being less than 0, that would be this part of the picture, right over here. This is where x is less than 0. And what is the function doing? Well, it's definitely increasing. But this part of it, my drawing's not very good, but this part of it is concave down, but this part of it is concave up. So I have like a point of inflection in there. And this says it's supposed to be concave down on the whole shebang, and it isn't. Okay? How about 7? Which one is false for 7? 3. And what's wrong with 3? Now be careful. This is a different thing. Question 3 says m of x is positive. M of x is y, right? So you need to be looking at all the parts of the graph that are above the x-axis. Now what are they supposed to be doing? They're all supposed to be increasing, are they?
Yeah.
Some of them are, but you have that little piece from -1 to 1 that's decreasing, and that's what makes that false. Perfect. And finally, number 8, what did you say there?
1.
What's wrong with 1? From -2 to 6, so basically, not quite, but almost the whole picture, it's supposed to be concave down. No, again, we have kind of a point of inflection in there, don't we? The first part of that picture is concave up, and then when it gets to about, I don't know, we could argue around 1 or 2 in that area, then all of a sudden it becomes concave down. Okay? Did you find that exercise kind of easy? Okay. All right, now I need you to get out your circuit training and how far did we get yesterday?
Halfway. I think we were like problem 8. Somewhere around there.
All right. Now, because I've had so much confusion, okay, and I need to say this. We cannot allow ourselves, you, and I mean you, cannot allow yourself to get all bogged down in one problem, okay? There's too many problems. You can't get bogged down in one. We also have to accept the fact that it's not always cookie cutter. Your math experience up to this point, pretty much cookie cutter. You have this kind of problem, you do this. You have this kind of problem, you do this. You have this kind of problem, you do this. That isn't the way it's going to work in calculus, and we are now preparing for calculus. So we have to sometimes think outside the box, not get frustrated, and not get all like freaking out and panicking, because there's one problem that's bothering us. So I know it doesn't bother everybody, but it bothers enough that we're going to talk about it again. And that is what we called, when we redid, we called it problem 3. And we used it for another problem, I don't remember which one, but we used it for another one. So I said, because we all think differently, and I can't think for you, you have to think for yourself, and most of you do a really good job of that. But I said, when I looked at this problem, the first thing that struck me was, it's quadratic. And when somebody says to me, you're quadratic, I immediately think this. That's what I think. But I knew that wasn't the right equation, because when I put in 0, I didn't get -3. So I, okay, all right, I'm gonna do this. This is a no calculator exercise, so I'm not allowed to use regression. If I were allowed to use regression, bingo, I'd be done. But I have to figure this out on my own. So this was my thought process. Okay, and I said, okay, that works for this point. Oh shoot, when I put in 2, I'm also supposed to get -3. So that told me that I don't have x squared, I have x times x minus 2. Because what happens when I put 2 in this factor? It makes 0. So wouldn't that give me -3? But when I put 0 in, I also get -3. So then I check this point. If I put 4 in, I get 4 times 2, which is 8 minus 3 is 5. When I put 6 in, I got 6 times 4 minus 3, which is 21. So I said, that's it. And then, I forget what the question was, I wanted to find f of 1. So I put 1 in, and I got -4. Okay? Then we had a couple other people had great ideas. So I sat down last night, and I tried to come up with a way. Some of you are very intuitive, that's magnificent. But I tried to come up with a way that those of you that can't see what's going on here, maybe this will help, and maybe it won't, I don't know. So here's the first part of the chart. 0 gives me -3, 2 gives me -3, 4 gives me 5. And the question involved, what's f of 1, right? Now, what does being quadratic mean? Being quadratic means that when you look at, let's say that's 5, and this is 7, that's going up by 2. So this one is going to have to be 11, because it's going to have to go up by 4, 2 more than that, and so on and so on and so on. That's what being quadratic means. It means this rate of change is changing by a constant rate. In this case, going up by 2's. Okay? Now, that's what's going to be happening over here. So I have no idea what this change is right here. So I'm going to call it x. I don't know what it is. But I know that this change then has to be x plus some other constant rate of change. And then this one has to be x plus two of those rates of change, because it's getting another c added onto it. And then this one would be x plus 3c, and this one would be, I gotta be careful here, I'm getting all confused. Okay, do I have to get all my numbers? Okay, so there's one, there's one, there's one. Okay, yeah. All right, now, what does that mean? Well, I don't know what these blank numbers are, but I do know that from here to here is a change of 0. So 2x plus c has to be 0 because these don't change at all. And then I also know that from here all the way down to here is 8. So all those have to make 8. So 1, 2, 3, 4 x's and 6 c's have to add up to 8. Now what's that? A little system of equations that I can, eliminate it or something. So maybe multiply that top one, so negative 4x minus 2c equals 0. And 4x plus 6c equals 8. So 4c equals 8, c equals 2. And if c equals 2, then x has to be negative 1. So from here to here is negative 1. Right? Which means f of 1 has to be negative 4. Negative 3 minus 1. Which is what we got when we did it this way. So this is the math behind a quadratic. Okay? I don't know if that helps or hurts, but that's another way of thinking about it. I think, Lauren, that's what you used. You didn't write equations and all that out for it, but I think that's what was going through your head. All right, so moving on, enough of that. Did we do number 8?
Yeah.
We simplified that. Okay, so the answer was 6. So then where do we go from there?
Back page.
Back page. Yep. The graph is shown. Which statement describes that? What's happening with that curve? Increasing at a decreasing rate. Bingo. Why is it increasing? Because it's going up. Why is it at a decreasing rate? Okay, down. You people are amazing. So now we're looking for 15. Where's 15? There it is. Yep. All right, so now we're looking at number 15. And we are going to compare rates of change. We have a picture that looks like this. Here's point A, here's point B. Now remember, rate of change is slope, right?
Yeah.
So if I want the instantaneous rate of change, that's just a tangent. I only have one point, it's at that point. So there's my tangent. I don't know what the slope of that line is, but there's a picture of it. Now, AB would be that line. Compare the slopes. Which one's bigger? The first line I drew or the second one? The first one. So we're supposed to, which is greater? So the answer is A, top one. So I go to answer 5, which is on the front. A linear function passes through the points -2, 7 and 0, 5. Find the average rate of change on the interval from 1 to 6. one moment. What kind of function is this? What do we know about linear? The rate of change is the same no matter what interval you look at, right? No matter what interval. So what if I just found the slope of this guy, the rate of change of this guy? Wouldn't that answer every interval? So if I minus 7, 0 minus -2, I got -1. Isn't that right? Now, could you write the equation of the line, find the y values for 1 and 6, and compute it that way? Yeah, but what a waste of time. It's linear, right? And that means the slope is always going to be the same. All right, so where am I going? To -1, which, help me out here. Second page. This is the family-friendly food truck problem. We're number 12, yep. Family-friendly food truck. Here we go. It gives me an equation, which, by the way, is quadratic, right? You recognize that? Okay. This revenue, when X dollars is charged for the dinner, what price should the chicken dinner be to maximize revenue? Okay, what pops into your head when I say maximize revenue?
Greater than or equal to.
Finding the highest point, right, on the graph? Well, this is a no calculator exercise. Now, clearly, if we had a calculator, could we type that equation in, second calc max, and we'd have it, right? What shape is this going to be? A parabola opening down. So what I am really looking for is the vertex of that parabola. Now, you learned how to do this last year. Actually, you learned at least 2 ways to do it. Does anybody remember either way of finding the maximum, Lauren?
You could find like the zeros and then it's
Exactly. So one way is to set the thing equal to 0. Now, don't be confused. It's already factored. It's already factored. So this means that either -1/2 x equals 0 or 2x minus 100 equals 0. Remember how when you solve a quadratic like this, you factor it, and then you set the factors equal to 0? That's already factored, so just set them equal to 0. So the zeros are at 0 and 50. Would everybody agree? And you already told me it opens down. Where's the vertex? Where x is 25, exactly. Now, what did we want to know? Did we want to know x? Yep, so we're done. So that's 25. Now, let me give you another option. This one was really easy to find the zeros. Remember, for a quadratic equation, can the zeros sometimes be yucky numbers? Like -5 plus or minus root 37 over 19, right? So while that will still work, it's still fine, it's beautiful, no issues. There is another way of finding the vertex that I find quicker and easier sometimes. Does anybody remember that other way? Remember that a quadratic function looks like this, right? You can find the axis of symmetry, which basically is the x-coordinate of the vertex, using the little formula -b over 2a. -b, opposite of b over 2a. That will work every time. So will this. Whatever flips your switch. Okay? All right, 25. Where's that one? Last page. now we got the band boosters. All right, what's your thought on that one? They paid $15 for a tumbler, plan to sell them for $20. What is your thought about that? What does break even mean? What you, however much it costs you equals however much you're bringing in, your income. So expenses equal income. Okay, so what are my expenses? 15 times 300, yep, 15 times 300, 4,500. All right, that's my expenses. Now, I need my income to be that. Well, what's my income? 20x, $20 for every one I sell. So my break-even point is 4,500 over 20, which is 225. I have to sell 225. That is an answer, I know. No, the other side. The Georgina fencing the pig problem. Everybody find it? It's gonna be number 14 for us. Georgina is going to fence in for pigs. How many of you have a fenced in backyard? Okay, I bet dollars to go nuts. You only have fencing on 3 sides because your house is the other side. That's what's happening in this problem. She's got the barn or the house or something, and she has 400 feet of fencing. So all of these have to add up to 400. These two are equal. Would you agree with that? What would this one be then? If she only has 400 feet and she put X and X, what would this be? 400 minus 2X? What's the area of that pen? How do you find the area? Length times width. Right? Now what are we trying to do? Find a, this is just like the one we did a minute ago. Is this already factored? So you can go ahead and find your zeros. Your zeros would be at 0 and 200, which means your maximum is gonna happen at 100. Is that okay with everybody? Now be careful, what do we want to know? What are the dimensions of the pen? Okay, so this is 100 and this would be 200. Search for the larger dimension. So now we're searching for 200. Everybody on target here, keeping up okay? Trying to get this done. All right. So what's next then? I gotta find 200. And front page. You said? We already 15. This will be number 15. To approximate the height of a rock in meters, here's my formula. What kind of equation is this formula they gave me? Quadratic. It asked me for a maximum. Here we go again. So my equation is negative 5t squared plus 10t plus 100. I want the maximum. Now this is a case where it might be easier to use my little formula that I put up there and then erase. What was that? X equals negative b over 2a. So my vertex is going to happen at negative 10 over negative 10 or 1, where x is 1. That's going to be my vertex. Okay? Now, what does the question want to know? What is the height of the rock? Okay, so x is the t, right? What do I need to find? Y, the height of the rock. And how will I do that? I just plug So if I plug it in, I get 105. That should be an answer, hopefully, 105. Yep. So now we're ready for number 16. Everybody okay? Here's the deal, folks. We could also have set this equal to 0 and solved it, right, to get the zeros. I know because I already did it. I'm going to divide everything by -5, so I get t squared minus 2t minus 20. That doesn't factor. So finding the zeros is going to be a little bit more complicated. That's why I chose to use my formula. You can still do it. It will still be fine. But this is just less arithmetic. Okay? Negative b over 2a. It's your friend. All right, 16. Graph is decreasing and concave up. Decreasing and concave up on what interval? Negative infinity all the way down to -3. Would everybody agree with that? What's the matter, Warren? Why don't you agree with that?
I do agree.
Huh?
I thought I was just saying concave up, so I
No,
thought
say
it was
decreasing and concave up. So that would be -3. Your answer is -3. And that, so now we're at 17, problem 17, we're almost done. I think there's 20. We already did it?
Well, me and Mendes, we missed it.
Oh, you
Yes,
messed up, so you already had it done? Okay, so since you've already done it, let's talk about your strategy here. This is really good. I love this. My x's, my inputs are going up by the same amount, so they're called constant size. That's not right, what they call it. The intervals are the same size, so that's what I want. Okay, now what's happening with my y's?
Divide 4 by 4.
A and B, okay. So what am I doing here? Explain why the function is not linear. How would you explain why this is not linear? It would take about 1 second. What's this change? Negative something, 576. What's this change? Not negative 576, right? And remember, if you're linear, you're going to have constant average rates of change, and I don't. Okay. Now, explain why the function is not quadratic. Well, this, I figured out my rates of change already, so I'll go ahead and do it. But this was negative 576. This one was negative 144. This one was negative 36. And this one was negative 9, and so on. It keeps going. Well, I guess I'm done then. Okay. How come it's not quadratic? Because how much is this changing by? Are these all changing by the same amount? That's the key. Because if they're quadratic, these would all have to be the same, right? And they aren't. Well, shoot. It's not linear and it's not quadratic. How am I supposed to figure out what it is? Well, you guys already did. You said we're dividing by 4. So if we divide by 4, then this change right here would have to be negative 9/4. And this change right here would have to be negative 9/16. Now, does that mean those are the A and B values? No. It means that to get from here to here, we're going down negative 2 1/4, which makes this number 3/4. And then we're going down 9/16. So 3/4 minus 9/16 is 3/16. 4 couldn't, anyway. So what do I wanna know? B over A. So 3/16 divided by 3/4 is 3/16 times 4/3, 1/4. Which jives completely with what you guys said, we're dividing our y's by 4. Okay, so hopefully 1/4 is in there somewhere. Oh, well, we almost got done. Tomorrow we're gonna do something different. If we have time, we'll finish that.
Religion and
But we're almost done.